The protection of our complex and fragile ecosystems is an enormous challenge. Nature is complex, and attempts at its exploration can often be dangerous or simply impossible. We benefit from long observation periods, such as weeks, months, or even years, to track any changes in the natural ecosystems. Since we rely heavily on many natural resources, drinking water being one of them, it is crucial to preserve them for future generations. Traditionally, manual water sampling is an enormous workload. It requires special equipment, teams, and facilities. It is made even more challenging with hard-to-reach habitats such as glacial lakes, groundwater, or other remote locations. A sampling expedition is needed to investigate the habitats of interest. The samples are then retrieved and analyzed in the lab. This consumes a lot of resources and is often very costly. This limits the data gathering process. This makes it challenging to detect sudden events, such as oil spills and other malfunctions. Sampling and traditional sensors give us precise measurements of biotic and abiotic factors. Biotic factors include biodiversity, invasive species, and trophic levels. Abiotic factors include oxygen, salinity, or temperature. The ROBOCOENOSIS BIOHYBRID project explores a new approach. It is meant to combine the benefits of sampling missions and traditional sensors. We observe the behavior of local species to read the environment. Their reactions give us a quicker insight into the overall state of the water. Organisms can tell us a lot about their environments. Their reactions show us the net effect of many complex processes happening in the lake. The challenge is, how can we observe them in their natural habitats long term? First, let's try a camera in a jar. From this, the biohybrid concept has stemmed. Combining living organisms with robotic-inspired solutions started the project ROBOCOENOSIS. The classic sensors here are not forgotten. We use them to compare the behavioral data with objective values. After all, we need to know what the animal is reacting to, and the sensor values help to narrow it down. We call this the calibration of the animal-based sensor. For this, we built an underwater sensor platform that records various environmental parameters. We included oxygen probes, temperature probes, and several others. We tested the biohybrid both in the aquarium and in the field. This is necessary because the results often vary between controlled conditions and real-life habitats. Various lakes served as testing fields. Lake Millstatt is a typical deep alpine lake. The water is clear, low in nutrients, and quickly gets colder with increasing depth. The clarity of the water reaches drinking quality, making it a dream tourist destination. Although it gets very deep quickly and the currents are strong. Its deepest point reaches 150 meters. Despite its apparent emptiness, the lake is teeming with life. The abundance of freshwater fish like trout, perch, and carp makes it a traditional fishing spot. Lake Neusiedl is a typical shallow step lake. It is one of the largest lakes in Central Europe, covering 315 square kilometers. Surrounded by vast reed belts and salt pans, it is home to several rare fish species, such as the zope or the Prussian carp. The lake is famous for its rich bird life and flora. Its waters are warm, muddy, and rich in nutrients. It shows huge changes in water level annually, which often result in complete drought. From jars to a robot. This project develops the methodology for animal-based environmental sensors. It lays the groundwork for future developments in the field of biohybrid robotics. This field of work helps to create a deeper understanding of our ecosystems and enables their better protection.